Hello everyone, welcome to a new video of Dr. Huffman Code. In this video, I'm going to talk about greedy strategy in data structure and algorithms. This is a very common and practical strategy for real-world application, especially for the time-sensitive application that doesn't require exact answer. If you stick around until the end of the video, I'm going to show you very practical example, including some algorithm that's still used until nowadays in real-world application, especially for the field of data compressions. For those of you who don't know me, I'm Dr. Duy Phan. I have been teaching more than 10 years at multiple top-tier universities. I also been programming for more than 20 years. I love programming and I love learning new knowledge. I also love sharing my knowledge to the community. Let's jump right into the definition of greedy algorithms. Greedy algorithms are the set of algorithms that always try to choose the best option at the moment without considering the consequences of that choice on the future steps. So the greedy algorithm doesn't look very far into the future. It only look at the next step. What are the options? And it will choose the best one, just solely based on the available information at the moment without considering the whole process. So it's very straightforward and simple. So what are the pros and cons of these strategies? Pros, these algorithms normally very simple. You don't need to have sophisticated data structure to store the historical data and take into consideration different roles. So it's very simple. You just choose the best one that you can see at the moment. It's efficient in terms of time and space. Like I mentioned before, it doesn't need a lot of space to store the different options, different parts. It only choose the available option at the moment, and it doesn't require a lot of computational time to take into the consideration of multiple options. Therefore, it's really efficient. It's fast, and the outcome is normally reasonably good approximation of the solution. So in many situations, an approximate solution is kind of enough for those applications. Then that is okay. So what are the cons of these strategies? First, it doesn't warranty the global optimization or the best solution, because like I mentioned, it doesn't take into consideration of the future. So it only takes the best option at the moment. So the best solution is not always warranted. It's not suitable for problems that require absolute correctness. Some critical problem that require exact solution, the most optimal solution, the best global optimization, then this strategy is not suitable for those applications. So let's jump right into the first example. In this example, I have a set of con denominations and a target amount. I want to find the minimum number of cons to construct that amount of money. The greedy strategy here is very, very straightforward, because I want to have the smallest number of cons. So my greedy strategy is that at every single step, I always try to choose the con that has largest denomination, right? At every single step, I always choose the largest possible con, so that I can quickly reach the target. In that way, I think that I will reach the minimum number of cons. Yeah, this greedy strategy makes sense, right? But it doesn't guarantee the optimal solution. Let's look at this example on the right over here. So I have a set of con denomination 1, 3, and 4. and my target number is $6. If I want to construct $6, I use greedy strategy that I proposed before. I will first pick number 4 because I pick number 4. What I have left from the target is 2. The only 2 options that I have, the only next option that I can choose is 1, and then after that I pick another one, another coin of $1. So overall, for the greedy strategy, I need 3 coins to construct $6, right? But the actual optimal solution, I only need 2 coins. I need 2 $3 coins. Then that will give me the optimal solution where I only need 2 coins instead of 3 coins. So the greedy strategy here doesn't guarantee optimal solution, but it's really straightforward and easy to understand and quick because it doesn't look ahead. It doesn't look into different options for the whole paths. It only look at the next available option and it choose the best one. And the best one is the coin with largest amount, right? So 4 and then 1 and 1. Okay, if you think my content is clear and easy to understand, make sure to like and subscribe to make it easier for you to see the future educational videos from me. Thank you very much. Example number 2, greedy scheduling. So one of the types of optimization problems that we encounter in a lot of real-world application is scheduling. So given a set of activity, each has a starting time and ending time. The goal is to select the maximum number of non-overlapping activities from this set. Okay. So the greedy strategy here is that we're gonna try to pick the valid activities with the smallest ending time first, because we want to maximize the number of activities, right? So the common sense here, greedily, we're gonna just choose the one that has smallest ending time so we can stack more activities after that one ended. Okay, so in my example, I have the set of activity here with the starting time and the ending time, 2, 5, 1, 3, 8, 10, 4, 7, and 6, 9. First, to perform this greedy strategy, I need to sort these activities in an increasing order of the ending time because I want to greedily choose the smallest ending time first, right? So gonna be the sorted list gonna be 1, 3, 2, 5, 4, 7, 6, 9, 8, 10. You can see here the ending time is in an increasing order, 3, 5, 7, 9, and 10. So the greedy strategy first will pick the activity with the smallest ending time, which is the first one, 1, 3. And then it look into the next one. The next one is 2, 5. But 2, 5 is not a valid one because we want to pick the activities that are non-overlapping as per requirement. Therefore, we have to pick 4, 7. After picking 4, 7, we cannot pick 6, 9 because 4, 7, and 6, 9 are overlapping. Therefore, we have to pick 8, 10 using the greedy strategies. So with the greedy selected activities, the solution is 1, 3, 4, 7, and 8, 10. For this particular case, the greedy strategies actually producing the optimal result. So it's not always bad. Depending on the problems and depending on your greedy strategy, sometimes you may be able to warranty global optimal. Okay, thank you for sticking until this moment. In this example, I'm going to show you the Huffman coding algorithms. This is a compression. This is a data compression algorithm, and it is lossless, so there's no data loss, and it's still being used in some of the compressing software until nowadays. So the problem here is that given a set of characters and their frequencies, construct a binary tree to create a variable length prefix free encoding for each character such that characters with higher frequency have shorter codes. The prefix free here characteristic here means a code associated with a character should not be present in the prefix of any other code. This is to ensure that there's no data loss. Every characters have a unique code and there's no overlapping of the starting of any character is actually another character. That doesn't happen with these algorithms to guarantee the lossless characteristics. Also, as you can see here, to compress the data with a bunch of text, we want to store the characters with the highest frequency with a sorted code. And we want to store the character with the lowest frequency with the longest code. Because the character that appear a lot, we should use less data to store it. And the character that appear not very frequently, we want to, it's okay to use longer code to store it, right? So the idea here is to first sort the input data, which are a bunch of character and the corresponding frequency into an increasing order. You can see over here, I have 5, 10, 15, 30, and 40% for the character X, Z, R, B, and A. So A is the most frequently appear characters, and its frequency of appearing is 40% of the text is 40% of the text are a bunch of letter A. Okay. So the greedy strategy here is I try to pick the characters or the node with the lowest frequency first when I construct the binary tree for generating the Huffman code. And the smallest characters are 5 and 10, 5 and 10, 5 and 10, we have 15, 5 and 10, we have 15 over here. So 15, 15. All right, so 15 is the total frequency of X5 and Z10. And this is a node, okay? Now this node will be part of the comparison for picking the greedy strategies. For the greedy strategy to pick the characters on the node, okay? So now we have 15, 15, and then the node 15. And I will pick these two. So these two are the next two smallest node or characters, right? 15 plus 15 is 30. So I have a new node here, 30. But I also have a characters B here, also 30. So these are the next two smallest characters or node. So B30 and node 30 will be combined into 60, right? B30 and node 30, they are smallest. They are both still smaller than A40. So these two will be combined together to create node 60. Okay, now both A40 and node 60 are the last two node or characters. So I just pick both of them and I combine them together, and I can see that the total frequency add up to 100%, which is perfectly correct. Now, once I have constructed the binary tree for my Huffman coding algorithm, I can generate the Huffman codes for all of my characters. You can see here the character with the highest frequency can take the value 0 as a code. So this is a very short code for a very highly frequently appearing characters. This character appear very frequently. Okay, so it has shortest code. The next character is letter B. Letter B code is 10. Letter B is the second highest, most frequently appear characters. So it has the second sorted code, which is 10. And then the next one is letter R. So from the tree, you can construct the code for the letter R, 1, 1, and 0. And then letter X and letter Z, we have 1, 1, 1, 0, and 1, 1, 1, 1, as you can see over here. So that's the result of the Huffman coding algorithm. As you can see here, with the greedy strategies, I managed to construct the binary tree to generate the code for each of the characters based on their frequencies. The character that has the character that have higher frequency will have shorter codes, and the character with lower frequency will have longer codes. This way, I can compress the data, and this strategy also makes sure that our algorithm is have generating the code that are prefix free. So there's no loss of data during the compressing process. Okay, so it's very practical and it's still being used. The Huffman coding algorithm is still being used in many data compression software nowadays. Thank you very much for watching, everyone. I hope you learned something, and thank you very much for being part of the QuadCon Code community. Make sure to like and subscribe to the channel to make it easier for you to see the next educational video from me. Thank you very much for watching again. Take care. See you in the next video. Goodbye.